Solving equations using subtraction. When you solve equations, sometimes addition will work, sometimes subtraction will work as your method of solution. In the problem we're going to look at now, we're going to use the method of subtraction by subtracting something from both sides of the equation. The problem that I've written on the board is 7 plus x is equal to 10. We carefully identify the variable as x. This is our unknown, and that's the variable we want to solve for. We want to know what x is equal to. I want the last line in my problem solving to be x equals some number. I need this x to be by itself in the problem. If I want the x to be alone, I notice that it's added to 7. Since 7 is added to x, I want to do the opposite thing to get rid of it. So I want to subtract 7 from this side of the equation. I know that 7 minus 7 will be 0, and that will leave the x standing alone on the left-hand side of the equation. I'm going to keep in mind that this is like a scale, and whatever I do to the left, I need to do to the right-hand side of the equation to keep it balanced. So I'll subtract 7 from the right-hand side of the equation as well. When I do that, 7 minus 7 is equal to 0, and I'm left with x on the left-hand side of the equation. And on the right-hand side of the equation, I have 10 minus 7, which is equal to 3. So the solution appears to be 3 to this equation. X appears to be 3. We're going to check the problem, of course, to make sure that our answer is right by using substitution. I have 7 plus x is equal to 10, but now I believe that x is equal to 3. So I'll have 7 plus x, which I now believe to be 3, is equal to 10. When I add these together, 7 plus 3 is 10, and certainly that's equal to 10. So the problem checks out. If I go back and review my problem, something was added to the variable, 7 was added to x, so I needed to subtract to get the x standing by itself. When I subtract from one side of the equation, I must also subtract from the other side of the equation. And I'm left with the solution, x is equal to 3. We're going to use the subtraction method to help us solve a word problem. Let's read the word problem together. It says Karen has $8. If Linda has 3 more dollars than what she currently has, she would have as much money as Karen. How much money does Linda have? As in any problem, it's important to find out exactly what it is you're looking for. In this case, how much money does Linda have? I'm looking for the amount of money that Linda has. So I'm going to let Linda's money be my unknown, be my variable. And I'm going to let Linda's money be represented by the variable L. That's what I'm trying to find out. If I go back and read the problem, it says if Linda has 3 more dollars than what she currently has, she would have as much money as Karen. In other words, if I added $3 to Linda's amount, she would have as much money as Karen does. If I look in the problem, I see that Karen has $8. So Linda's money plus $3 would be equal to $8. The equation that I'm solving is L plus 3 is equal to 8. Now in this problem, you can see that the L is what I want to have be by itself at the end of the equation. I'm solving for L. So what I want to do is get rid of that plus 3. Since 3 is added, I want to do the opposite thing to both sides of this equation. I want to get rid of this 3. The way I'm going to do that is by subtracting 3. And as always, whatever you do to the left-hand side of the equation, you must always do to the right-hand side of the equation as well. So I'll subtract 3 from both sides of this equation. When I do that, 3 minus 3 is going to be equal to 0. That number is gone now, leaving me with L, Linda's money, is equal to 8 minus 3, or 5. And we believe that Linda has $5. We want to check our solution with the problem to make sure that it makes sense. So it says if Linda's money, $5, was increased by $3, it would total Karen's money, which is $8. When I check, Linda's money, 5, plus 3 more is equal to 8, and my problem checks out. So I'm confident that my solution is really $5. Linda currently has $5, and we did this problem by using the subtraction method.
This is a construction scene in New York City. The owner of the crane says to you, to operate this crane, I figure my profit plus the cost of $195 per hour comes to $280. What is the owner's profit per hour for this crane? But before we solve this equation, watch these men placing this prefabricated I-beam in its proper place. Think of the cost if this I-beam was not at the proper length. Also, how would you like to walk along this I-beam? Let's do this problem. The problem states the owner's profit per hour plus the cost of $195 per hour comes to $280. Now I'd like to explain a little bit about the cost of $195 per hour. And you know, when you have a big machine like that crane that you saw in the picture, there's overhead costs. There may be payments that you have to make on that crane. There's the fuel, there's the wages, and the storage, and there's a lot of wear and tear on a piece of equipment like that. So that's what that cost of $195 per hour means. And the question is, what is the owner's profit per hour for this crane? So we want to find the profit for the owner. So we're going to make that P. And so the owner's profit per hour plus, and that's the key over here, plus what? Plus the cost of $195 per hour. So that's $195 per hour comes to, and that's your equal sign, $280. And so now all we have to do is the math, and remember what you do on one side of the equation, you have to do on the other side of the equation. So we're going to deduct $195 from this side and deduct $195 from this side. This will cancel this. And so P equals, let's do the math over here, 280 minus 195, 7. 5 from 10 is 5. Borrow 1 from here. 9 from 17 is 8. So P equals $85. So the profit per hour for that crane is $85 an hour.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.